In this video, we'll be talking about how to multiply fractions, and by the end of this video, you'll have the tools to tackle any question involving multiplying fractions or mixed fractions. The timestamps will refer to when we talk about the basics of multiplying fractions, the cancellation method, and an example involving a mixed fraction as well. It's Rami here, let's get into it. Some of you may be familiar that when multiplying fractions, we can just go right ahead and multiply the numerators of the fractions together to get a new numerator, and multiply the denominators of the fractions together to get a new denominator. But why do we multiply them in this way? As many of you likely know, fractions are parts of things. So when we multiply fractions, we can think of it as finding parts of those parts. Suppose you have one whole pizza. If we slice this in the middle, we see that we have half a slice of pizza. Now let's focus on each half slice and split each half into three further parts. Focusing on this slice for just a moment, we can see that this represents 1/6 of the total of the pizza. This is because this is 1/3 of 1/2 of the pizza, which gives us 1/6. Now, just looking at the fractions, bearing in mind that 1/3 of 1/2 is 1/6, for those of you unaware, the word of in maths is often referred to as meaning multiplied. So if we now replace the word of with the multiply symbol, and the word is with equals, 1/3 of 1/2 is like saying 1/3 times 1/2, which appears to be equal to a sixth. So when multiplying the two fractions together, a handy shortcut here is to simply multiply the numerators of 1 and 1 to make 1, whereas multiply the denominators of 2 and 3 together to make 6. And we can apply this rule for any fractions that are multiplied together. So a pro tip here is that when multiplying two fractions together, we could just multiply the respective numerators and denominators of those fractions. In the next section, we'll look at multiplying two different fractions together. For this question, following our tip that we just learned, all we need to do is just multiply the numerators of 2 and 1 together to get 2, and then multiply the denominators of 3 and 4 to get 12. This leaves us with 2 over 12. But we're not necessarily quite finished because we see the statement simplest form. Let's have a quick recap of what it means for a fraction to be in its simplest form. Moving away from our example for just a moment, as some of you may be aware, a fraction is said to be in its simplest form when the numerator and denominator have no common factors other than 1. For example, we know that 2 over 4 and 1 over 2 are the same thing as they both represent 0.5. However, 1 over 2 is considered to be in its simplest form because when you divide the numerator and denominator of 2 over 4 by 2, you get 1 over 2. So we'd often prefer to write 1 over 2 rather than 2 over 4. So applying what we just talked about to our question, notice that both the 2 and 12 both have a common factor of 2. So we can divide both the numerator and denominator by 2 to get 1 over 6. And now that's the answer in its simplest form, so that's the question complete. In the next section, we'll now look at a slightly harder example, which can be done in two different ways. For this question, as mentioned, there's two ways to do this. The first method we'll use is to multiply the fractions, then simplify from there, and we'll talk about the second method straight after that. So the first step is to multiply the respective numerators and denominators together. When multiplying the numerators, we get 3 times 4, which makes 12. And when multiplying the denominators, we get 8 times 15, which makes 120. The second step is to simplify the fraction. Some of you may notice that the highest common factor of both 12 and 120 is 12. So when we divide the 12 and 120 by 12, we get left with 1 over 10. And that's the fraction in its simplest form, since there's no common factors here other than 1. Let's talk about the second method for the same question. For the second method, we'll use what's known as the cancellation method before multiplying our fractions. In order to do this, the first step is that we'll often just find convenient factors, or the highest factors, between the numbers in both the numerators and denominators. In order to show you this cancellation method a bit more clearly, in this box on the side, I'll write down an alternative way that you can think about this, but you wouldn't normally write what's inside the box in an exam. Notice we have 3 times 4 as the numerator and 8 times 15 as the denominator. If we were to divide the numerator and denominator by 4, this is like having 3 times 1 in the numerator and 2 times 15 in the denominator. This leaves us with 3 over 30, and when we divide the top and bottom by 3, this simplifies to be 1 over 10, which is the same as the original answer. So if we refer back to our original fractions, in order to use the cancellation method successfully, we just divide the second numerator by 4 and the first denominator by 4, since they both share a common factor of 4. So this means our first fraction would be 3 over 2, whereas our second fraction would be 1 over 15. If we were to now bring these fractions together to make a new fraction, we'd multiply the numerators to get 3 times 1, and multiply the denominators to get 2 times 15. This would give us the working I showed you in the box previously. So a pro tip here is that when applying the cancellation method, when we see common factors between one of the numerators of the fractions and one of the denominators of the fractions, we can divide those numbers by that common factor. We could now multiply these two fractions together before simplifying. However, I notice another common factor between the numerator of the first fraction and the denominator of the second fraction. Let's apply this cancellation method again. Notice that the first fraction numerator and second fraction denominator have a common factor of 3. Therefore, dividing these numbers by 3, this leaves us with just 1 and 5 respectively. Now we're just left with these much simpler looking fractions of 1 over 2 multiplied by 1 over 5. I think we can all agree that multiplying 1 over 2 times by 1 over 5 is easier than the original fractions since we're dealing with much smaller numbers, and yet we'd still get the same result. Now that we can't cancel these fractions anymore, so the second step here is to just go ahead and multiply those fractions together like we normally would. So in short, this gives us 1 over 10. No further simplifying is needed, but if there was need to do so, do make sure you do that. You'll notice that this answer is exactly the same as the answer that we got from the previous section of the video. So clearly this method worked. So a pro tip here is that the larger the numerator and denominators are in the fractions, the more likely that you'll just want to use the cancellation method of multiplying fractions, as it can reduce the likelihood of making mistakes, and we're less likely to deal with really large numbers. We'll use the cancellation method again in our next question. This time, we have a mixed fraction multiplied by a fraction. We'd like to follow the original methods that we've been using previously, but the issue is that 2 1/4 is a mixed fraction. In general, we can only multiply proper or improper fractions using the methods that we learned previously. So the first step is to convert 2 1/4 to be an improper fraction. We'll multiply the whole number of 2 by the denominator of 4 in the fraction to make 8, then add the 1 to make 9, leaving us with 9 over 4 times by 2 over 9. The second step will be to multiply the fractions using the previous methods that we've done before. I see quite a lot of common factors that we can cancel, so I'm going to use the cancellation method that we just learned previously. I see that for the first fraction numerator and the second fraction denominator, they have common factors of 9, so we'll divide them both by 9. Likewise, I see that the second fraction numerator and the first fraction denominator have common factors of 2, so we'll divide both of them by 2. This leaves us with 1 over 2 times 1 over 1, which I'm sure you'll agree is much easier to work with than our original fractions. When multiplying these two fractions together, we just get left with 1 over 2. So a pro tip here is whenever you see a mixed fraction multiplied by anything, we always want to convert any mixed fractions into improper fractions. So we've talked about why we multiply numerators and denominators of fractions, an example of how to multiply two fractions together, and how to multiply fractions when we have a mixed fraction involved. So now you've got the skills in order to go right ahead and practice some similar questions. So that's going to do it. I hope you managed to get something out of today's video. Don't forget to subscribe for more free content just like this, and turn on all notifications so you don't miss any uploads from this channel. If you have any questions, just pop them in the comment section below. Thanks for watching, and I'll catch you in the next video.